My guest today is Andy May.
I've been writing about climate science in general for about 13 years. This is my latest talk. The IPCC, or the Intergovernmental Panel on Climate Change, AR6 report, and the so-called climate consensus cabal hide and suppress many inconvenient truths that run counter to their hypothesis that man-made climate change is dangerous. I will list and discuss some examples in this talk. More are explained in our recent book, The Frozen Climate Views of the IPCC, an Analysis of AR6. But first, some personal examples of the suppression of non-consensus climate ideas. Both of these papers were invited. Both passed peer review and/or editorial review, but they were ultimately rejected by people higher in their respective organizations just before the scheduled publication date, with no valid reason given. I took this as a clear sign that both rejections were purely political. After all, any technical reasons for rejection should have been voiced during the review process. The PET-M paper on the left was invited by the Rocky Mountain Association of Geologists, or RMAG. They intended to publish the paper in their online publication called The Outcrop. Articles for The Outcrop are reviewed by the staff and editors, but not in a formal way as academic journal articles are. The paper's rejection was not for technical reasons, but was blatantly political, and after months of work by the editor, another RMAG staffer, and by me. The rejection was a board decision done at the last minute and without explanation or justification, except to point out that I am not a trained climatologist and I'm a blogger. Thus, it was pretty clear that the paper was rejected not because of any problems with it, but because of who I was. When I complained, the board sent the paper to yet another reviewer after the paper had already been reviewed and accepted. The additional reviewer was sent an early draft and not the final version. In a conference call, he pointed out several flaws that I knew were not in the final version, causing much confusion, until I realized he had the wrong version of the paper. Thus, the board either did not see the final version when reversing the decision of the editor and the peer reviewers, or sent either deliberately or by accident their extra reviewer the wrong version. I explained all this, but it was rejected anyway without reconsideration or even a look at the final draft. Thus, it was clearly a political decision based on the conclusions of the paper, the fact that I am not a trained climatologist and I'm a blogger. The paper now appears on my blog and has been one of my most popular posts. The second invited but ultimately rejected paper was written for the Creative Society at their request. They specifically wanted me to write a paper on climate shifts, such as those that occurred about 1925, 1947, 1976, and 1997. They asked me to present it in an online interview on October 10th, 2022. The interview was recovered, and when I asked when it would be posted online, they said they would have to get back to me. They never did, so I posted the paper on my blog. I was never given a reason why it was not posted online by the Creative Society. The discussion on climate shifts was very interesting since they believed that they might be related to changes in Earth's mantle. Wolfgang Wagner, then editor-in-chief of the journal Remote Sensing, resigned over a perfectly reasonable but counter to the consensus paper by Roy Spencer and William Bracewell in 2011. Spencer and Bracewell presented solid observations and facts, and their critics presented only model results. The debate between the two sides is complex and mostly over the sign and magnitude of feedbacks to greenhouse gas, mainly CO2, warming. This is how science is supposed to work. When an editor proclaims from on high that one well-supported opinion is wrong and the other is correct, without proper discussion and debate, it is politics, not science. Willie Soon and Dick Lindzen report that 2 editors were fired for publishing 2 of Lindzen's papers. The first, published in 1990 on the left, lays out Lindzen's objections to the idea that a man-made enhanced greenhouse effect could be the dominant reason behind current warming. The paper is quite reasonable and certainly not a reason to fire anyone. The paper warns that more definitive evidence of the potential dangers of man-made global warming must be found before drastic actions like eliminating fossil fuels are taken. We must remember that climate model results are not evidence, they are conjecture. Lindzen's paper is still viable today since definitive evidence and examples of man-made climate change dangers have not been found even 34 years later. This is well illustrated in Table 12.12 of AR6WG1 on page 1856, shown a little later in this presentation. The second is Lindzen's landmark first paper on the iris effect on the right. Now, more than 23 years later, the iris effect is widely accepted, and when incorporated into climate models, it moves model results closer to observations. Certainly, accepting such a landmark paper is no reason to fire anyone. One must remember that Albert Einstein's first PhD thesis was rejected. Years later, he submitted a series of papers to Max Planck at the Annalen Physik Journal, and one of them was accepted as his thesis, and he finally got his PhD. Planck published Einstein's new thesis and several other papers without formal peer review, and Einstein's reputation was made. Max Planck said that publishing risky papers is important. It is far worse to reject a possibly groundbreaking work. The peer review process can, and often does, suppress truly innovative work. Papers are sometimes rejected simply because they are novel and opposed to the consensus position. Today, the iris effect is discussed in detail in the IPCC reports, although often without mentioning Dick Lindzen's name. And a search using Google Scholar shows 7 published papers since the original paper was published in 2001. 5 of them were published after 2015, and the most recent in 2022. This major discovery was reported in a journal that fired the editor for publishing it, and now the discovery is well-established science. I could find no evidence that the professors who rejected Einstein's thesis were fired. And what Roger Pielke Jr. calls the most egregious failure of modern scientific publishing, this perfectly fine paper by Gianluca Alamonti and his colleagues was retracted due to pressure from the consensus and the mainstream media. Pielke Jr. believes that the retraction was based solely on the following sentence from the paper. In conclusion, on the basis of observational data, the climate crisis that, according to many sources we are experiencing today, is not evident yet, which is simply the same thing that AR6WG1 says, just with fewer words. As we will see in the next slide, the Springer Nature retraction notice contained no substantive issues with the paper. It just says concerns were raised. Here we see part of the previously mentioned Table 1212 from AR6, Chapter 12, page 1856. The right-hand column of the paper shows detected climate change impact drivers that can be seen today or in Earth's recent history, that is, since 1750 or later. The IPCC defines climate change impact drivers, or CIDs, as physical climate system conditions that affect an element of society or ecosystems. Human-caused CIDs can be detrimental, beneficial, neutral, or a mixture of each across regions of the Earth. That is, a particular change in climate can be beneficial in one part of the world and detrimental in another. This is obvious, but often ignored by the climate establishment, which tends to only consider the negative impacts of climate change. A climate change impact driver is defined as a change that has exceeded a signal-to-noise ratio of 1. It occurs above a defined level of random change, the so-called noise level. Thus, the definition of climate change is statistical. It takes time to tell whether a particular change is real, that is, a change in climate as opposed to weather. Roger Pielke Jr. and his colleagues found that even if a particular change occurred, we could not be sure it was real climate change for over 100 years. It would take that long just to gather the necessary data to show the change had emerged from the noise. As the legend shows, orange means a decrease and blue means an increase. A white box means no change is detected above the noise level. The tropical cyclone box is white. Likewise, the boxes for wind speed, drought, flooding, precipitation, wildfires, landslides, ocean acidity, and sea level rise are white, meaning no significant change is detected. An increase in incidence of extreme heat is detected, but the footnote limits this to some tropical and mid-latitude regions. So even an increase in extreme heat events is not apparent globally. There is a decrease in cold spells and an increase in mean air temperature in most regions. Likewise, there is a decrease in permafrost in lake and river ice and an increase in mean ocean temperature. So if the scientists only found these obvious changes that are largely benign, why do the politicians act like the world is coming to an end? This is what we must ask ourselves. I guess they didn't expect anyone to read all the way to page 1856. Ideas that go against the consensus can get editors fired. They can also be suppressed by mindless bureaucrats who haven't read them even after the peer reviewers have approved them. Sometimes politicians can change what the scientists have written to achieve political ends. This happens in every IPCC report. Each report has a political section up front called the Summary for Policymakers. This summary is written by politicians for politicians. It is distinct from the rest of the report that is written by the scientists who did the work and does not say the same thing. In this slide, the quote from chapter 11 at the top describes the scientific findings. They have low confidence that any trend exists in tropical cyclone intensity, frequency, or duration over the past 40 years. They also expect the global frequency of cyclones to decrease or remain the same in the future. Although they believe the most intense storms will increase in some places, but not globally. They have medium confidence that there will be a reduced frequency of mid-latitude cyclones due to anthropogenic climate change. How is this presented in the summary for policymakers written by politicians on page 8? They say evidence of observed changes in extreme weather and the attribution of these changes to human influence has strengthened since AR5. Who do you believe, the scientists or the politicians? You can't believe both. You'll notice that the alarmist statement is on page 8, and the scientific discussion is on page 1583. The IPCC and Al Gore like to tell us that higher temperatures will lead to stormier weather. Research by many climate scientists, including Zhongwei Yan, Phil Jones, Anders Moberg, Susanna Costas, Felipe Sorel, and many others dispute this idea. As the planet warms, the equator to pole temperature gradient decreases since tropical temperatures barely change. A smaller equator to pole temperature gradient provides less power for storms. Earth's atmosphere is like a heat engine. It is powered from below, and as the heat moves through the atmosphere, it does work, just as the steam moving through a locomotive does work on its way to the smokestack. The work it does is our weather. When the gradient is steep, as in the Little Ice Age, it does more work and the world is stormier. Leon Barry tells us that most heat is moved from the tropics to the poles by mid-latitude storms. If there is less heat to move, there are fewer and less severe storms. Zhongwei Yan tells us that extreme weather has decreased since the 19th century, especially in the winter months. Work by Roger Pielke Jr. and Bjorn Lomborg confirm this trend. On longer timescales, we see that storminess has greatly decreased since the Little Ice Age, which is labeled LIA in the figure in the slide. We are constantly told that the rate of global mean sea level, or GMSL, rise is accelerating. Is it? How definitive is the evidence? If it is accelerating, why? Is the acceleration dangerous? We will remember from a previous slide that AR6 concludes that any recent change in the rate of sea level rise is not above the noise in the measurements. In fact, a change in the rate of sea level rise is not expected to be detected globally before the end of the 21st century, except possibly using the extreme and unlikely RCP 8.5 scenario. The usual assumption is that it is rising mostly because of man-made global warming and the resulting melting of glaciers and the polar ice caps. Is this true? Maybe not. Dangendorf et al., the green line record in the graph, find a persistent acceleration in GMSL since the 1960s and demonstrate that this is 76% associated with sea level changes in the Indo-Pacific and South Atlantic. They also show that the initiation of this recent acceleration in sea level rise is tightly linked to changes in southern hemispheric westerly winds. Thus, much of the change in the rate of sea level rise in the 1960s is linked to changes in regional atmospheric circulation, not melting glaciers. In absolute elevation, sea level is not the same in every ocean basin. This is due to the shape of the ocean basins, the individual ocean basin temperature, and the strength and direction of the prevailing winds in the basin. Thus, the acceleration of sea level change in each ocean basin is different. The global mean sea level is a combination of all the changes in each basin, and just reporting or discussing global changes in sea level masks a lot of complexity. Global sea level is not global at all. It is largely a rise in sea level in specific regions. It is interesting that no acceleration is detected in the Eastern Pacific or in the Arctic Ocean, and deceleration is detected in the Southern Ocean. Thus, the regions that should be most affected by melting ice, the Arctic and the Southern Ocean, show no acceleration in the rate of rise since 1960. You will notice there is a cyclical acceleration and deceleration in these records with a period of about 65 years. It is most easily seen in the blue Jevra record and the green Dangendorf record. We are now in the upswing of the rate of sea level rise that began between 1970 and 1990. We are currently about halfway through a cycle near the peak that is expected to end around 2050. This is a graphic showing the IPCC modeled components of global warming since 1750, just after the end of the worst part of the Little Ice Age. Their models say the sun's variability had essentially no impact on global warming, or perhaps a very small negative impact. They claim volcanoes have a slightly larger negative impact on global warming, so all the warming is due to human activities in their model. This might be correct, but who knows? The alternative idea that nature caused some of the warming is still entirely possible and should be investigated, not ignored. This graph compares various solar activity reconstructions from sunspot observations. Sunspots are considered a good proxy for solar output, with high sunspot counts equating to higher solar radiation output. Grand solar minima, such as the identified Maunder minimum and the Dalton minimum, are readily recognized, since the amplitude of the Schwabe 11-year solar cycle is very reduced in these times. Grand solar maxima, such as the modern solar maximum from about 1930 to around 2010, are harder to see. These are periods when the smoothed sunspot number remains above 50 for 2 solar cycles or longer. The modern solar maximum lasted about 80 years and was centered in 1970, according to Ilya Usoskin. This is the longest solar maximum since 1200 BC, 3,200 years ago, according to solar proxies. Solar maxima do not have an instantaneous effect, since the change in solar output is small, and they work by accumulating excess thermal energy in the climate system, especially in the oceans. Very little energy escapes directly to space from the oceans. It must first be transferred to the atmosphere and carried to a location and altitude where it can escape to space. Here we compare the same sunspot records to the Hadkrut 4 surface temperature anomaly. We notice the late 19th century temperature decline as solar activity decreases to a minimum around 1910. Then they begin to rise rapidly until the 1940s and ultimately fall until about 1976 as solar activity drops a bit during the 1960s and 1970s. Then temperatures began to rise again in the 1980s and 1990s, only to stall in the 2000s prior to the 2016 Super El Nino. The modern solar maximum is now over, so some reduced rate of warming or even cooling in the next few decades is to be expected if solar variations make a difference. Censorship is an ugly thing. It has happened to presidential candidates and to scientists. It has happened to me. Censorship for any reason other than to protect children from age-inappropriate images and text is both unscientific and wrong. The main job of any scientist is to challenge accepted ideas with data and analysis. Science is incompatible with censorship. We constantly hear from the news media that human-caused climate change is dangerous now, or that we are seeing signs that serious climate change disasters are imminent. Yet the only observed so-called dangers are the world is a little warmer and CO2 has increased in the atmosphere. These obvious changes have simply made the world a greener and better place. All the supposed dangers are projected into the future by climate models, and the climate models have been shown to be inaccurate. Warming occurs mostly in the higher latitudes. Temperatures in the tropics barely change and are limited to about 30 degrees C by evaporation and the resulting deep convection of warm, humid air that forms clouds. The transport of heat from the tropics to the poles acts as a heat engine that produces our weather. The more heat transported, the stormier it is. Thus, as the higher latitudes warm, aka global warming, less heat is transported to the poles and fewer and less severe storms form in the mid-latitudes. All the data collected in the 20th century suggests that storminess is decreasing as the world warms, not increasing. Sorry, Al Gore. Sea level rise since 1900 is about 96% linear, using all the common sea level rise records. The apparent acceleration seen since 1990 coincides with an upturn in the AMO, or the Atlantic Meridional multi-decadal oscillation, and other ocean oscillations, and is probably natural. Blaming it on human activities is premature. We won't know for another 30 years after the ocean oscillation turns negative. The sun is far more variable in its effect on climate than assumed by the IPCC and the climate consensus. Further, these known variations in the sun correlate very well with historical climate changes. The bias in the UN climate change reports is mostly selection bias. They only choose papers that support their thesis that humans control the climate and ignore the abundant literature that shows nature through cloud cover, ocean oscillations, and the sun have a large effect, probably the dominant effect on our long-term climate. This censorship by omission radically misinforms the public. Science is the well-established process for one person or one small group to show the world that their cherished beliefs are wrong. It only works in an open world with free speech and a free press. Censorship, suppression of speech, and consensus thinking are the enemies of science and truth. Censorship and the suppression of free speech destroy innovation and human progress. In a world where consensus rules and new ideas are suppressed, would a personal computer in every pocket and purse or a SpaceX Starlink exist? No, these were the visions of a few individuals under the leadership of Stephen Jobs and Elon Musk, respectively. Others would think the ideas were crazy, like Einstein's thesis or Richard Lindzen's iris effect hypothesis. The so-called consensus is the enemy of innovation and truth. Much more detail on the serious omissions and bias in the latest IPCC report called AR6 can be seen in this book, edited by Marcel Kroc and myself. Okay, Tom, that's it.
You gave this talk in Houston. Now, did you get some good questions afterwards, or what was the reception there in Houston?
It was good. It was good. The meeting was well attended. There were lots of really good questions. Most of the questions revolved around the stories earlier about the retracted article by Alamonte and Richard Lindzen's two papers that caused people to be fired. One fellow remembered Lindzen's first paper in 1990, and he didn't know that the editor had been fired for publishing it. He was shocked about that.
Do you think peer review in general is just broken and we should get rid of it, or can it be saved, or what's the future of peer review?
I think peer review is broken. It's unfortunate, but there are just a few publishing companies that that publish most of the peer-reviewed articles. You know, there's Springer Nature, Elsevier, and Wiley, and then there's a few overseas that don't have the prestige that those three have. This gives the larger publishing companies an awful lot of say, and too much say, really. And I've watched the process from the inside, and I've seen them affect what articles get published. Certainly they affect what articles get retracted, like Alamonte's fine paper. So it's a combination. The peer review process itself is a burden, particularly when it's anonymous. The writers of the articles don't have any say in the peer reviewers, and the editor can send them to whoever they want. Editors are very much affected by the fact that other editors have been fired for publishing controversial papers or innovative papers. We've seen examples of Einstein's example, Linsen's example of innovative papers that were controversial when they actually came out. So, no, I think peer review is definitely broken, particularly in climate science. It's broken in economics. It's broken in medicine, and it's broken in the social sciences, and especially. I'm not so sure there are flaws in my fields that are apparent yet, petrophysics or physics or geology. Those areas seem to be doing a little better, but certainly in the sciences that I listed, and especially climate science, I think it's broken. It needs to be either just thrown out and let the editors decide, or it needs to be drastically revised in some fashion.
Do you have any predictions at all about the future of either the IPCC or the COP meetings? Do you think 10 or 20 years from now, they're still going to be going great guns as they are now? Are they going to peter out or what?
They should. I mean, it's been 34 years since the first IPCC report came out, and they haven't made any progress in measuring the impact of CO2. I mean, zero progress. So if anything, they're going backwards, as admitted in AR6. They're getting worse. So in terms of accuracy of the models, and the models are the whole story. So I would certainly hope someone would pull the plug on this eventually. I'm surprised it's still going. I would have thought that ClimateGate in 2009 would have killed it, but it didn't. And there's more and more papers coming out that are critical of the IPCC and their lack of progress in figuring out how CO2 affects climate. So I would hope in 20 years it would be dead, but 2009 was 15 years ago, and that really blew the lid off of it. So I don't know. You remember there was major criticism after the second report came out, the so-called SAR report. I mean, and that was in 1996, almost 30 years ago. So it's survived. I guess the attraction of all those hundreds of billions of dollars and the intransigence of the politicians who want a global government to form out of this is just overwhelming so far. I don't understand.
I mean, I'm constantly reading this narrative that, we really weren't that alarmed 10 years ago, but now we've learned stuff and now we're more alarmed. But they never say what we've learned that made us more, more alarmed. Have you heard specifics about what should make us more alarmed now than 10 years ago?
No, quite to the contrary. I think the published research in the area over the last 10 years should make people less alarmed and make them realize that nature is playing a large role in this. And CO2's influence on climate, if it even exists, is is getting smaller and smaller, uh, in my view.
And then a specific question is how about the 1976 Pacific climate shift? Do you think sunspots might be the best explanation as to what caused that to happen?
It's probably at the root of it. A change in solar output, but unfortunately, exactly how that works is unclear. The uh, you can see correlations with solar activity in these climate shifts, and you can see correlations with impact on the ground. Uh, a lot of these are detailed in Javier Vinos's book, but the exactly how it works, I don't know. Except it does seem clear that the oceans act as an accumulator of sunlight, the energy from sunlight. Sunlight can penetrate the ocean surface, go as deep into the ocean as 100 meters, and and changes in sunlight have a big effect on ocean temperature and ocean temperature trends. Uh, Radiation from CO2 and other greenhouse gases can't penetrate the ocean, so they have a very, very small effect on ocean temperature, which is where 99.9% of the heat on the Earth's surface is stored. And you got to remember, the atmosphere is not significant in climate really, because it's got such a small heat content. And really, the atmosphere just rearranges heat on the Earth's surface and manages to get heat from the ocean, which is the important thing, to outer space. But it does it in a complicated way uh, that is affected by winds and these weird climate shifts that we can observe but can't really explain.
Is there any dynamic where the warming climate shifts can happen very quickly and the cooling happens more slowly, or is it kind of symmetrical and we could have a dramatic cooling that happened pretty quickly?
I That's a good question. I've never thought about it, but I think you're right. I think the cooling shifts occur more slowly. Um, that's probably because of the dampening effect of the oceans. Uh, Cooling periods usually begin with an increase in El Ninos and hurricanes and such. If you stop and think about it, that's pretty logical because they are the vehicles for getting large amounts of ocean heat into outer space. El Ninos take heat out of the ocean and spread it all over the world, warming it, and then eject it to outer space. Hurricanes do the same thing. Cyclones do the same thing. Uh, so you have this kind of flurry and extreme weather, and then the Earth begins to cool after that. We've had a lot of El Ninos recently. The 2016 El Nino was really big. This recent heat wave, probably caused by the Hunga Tonga volcano, is another mechanism for getting heat into outer space. So the trend seems to be right now that we are headed towards cooling, but we'll see. I mean, no one knows for sure.
Okay, so that's interesting. We had a lot of, I think, extreme weather and warming in the 1930s. You think that was kind of a setup for the cooling that followed from the 40s to the 70s?
That would be my assumption. I can't prove it, but you're quite right. The weather was very extreme in the 1930s, and then by the time we got to 1944, the world was clearly cooling, and the right after World War II, and it cooled until 1976, until uh, that major climate shift caused warming to begin.
Okay. Any other points you want to make here before we finish up?
No, I might add that there is a correlation. Not that correlation means anything's causing anything, but there is a correlation between activity in the upper mantle of the Earth and these climate shifts. I didn't know this until I did the Creative Society video meeting that I mentioned earlier in the talk. But the reason they asked me to give the talk on climate shifts was they noticed that the correlation was there. So that's something to think about, probably something to consider. I just mentioned it because I don't really know much more than the correlation exists. I don't even know how the mechanism would work. But it's an idea for people to consider.
All right, very good. All right, and I just tweeted while you were talking that I really like your work. I think it's incredible. It's great work in terms of so calm, so much data, and I think people should listen to you and not Greta. That would be a much more sane world. So thank you.
Okay. Thank you, Tom.
All right, Andy May, we'll talk to you next time. Goodbye.
Sure. Goodbye.